Okay, so now we have reached the fourth subtopic called the conservation of angular momentum. Okay, let us discuss this question. Figure above shows two circular discs. This A is stationary, while this B is rotates with angular velocity 150 radian per second. Okay, initially A is not moving, but B is rotating. Moment of inertia of A and B about axes, which pass through their centers are 0.5 and 0.3 kilogram meter square respectively. So given their moment of inertia, okay, IA and IB. Now A is moved towards the B until it touches B. Okay, A later combine with B. Because friction exists between the surfaces, they finally rotate together. Now they combine, they rotate together with the same angular velocity omega. So omega is the final angular velocity after they combined. If no other external force acts on them, determine the angular velocity omega. That means you want to find the final angular velocity. After they combine. So we have the initial angular velocity and also given the IA and IB moment of inertia. So now what to do? Okay, so we use conservation of angular momentum. So this is the IAIB. This I picture out the situation. It's always a good practice to picture out our situation in the physics, so that we have a clear picture. And once we have the clear picture, we can use the right concept, right principle to solve our question, isn't it? So always picture out our situation in a simpler terms. Okay, so we have the B is rotating initially with this initial angular velocity. Now they combine A and B. What is the final angular velocity? So this one use conservation of angular momentum. In linear motion, we also have conservation of momentum. So this is similar. In fact, momentum in linear motion we have P equal to mv. P is the momentum. Now L, we use L in rotational motion. We use L for angular momentum. Then mass is like moment of inertia. Velocity is like omega. Okay. So this time we use L, we use I omega. So total initial momentum, angular momentum equal to total final angular momentum. So they are I omega initial equal to I omega final. Alright. Initially, what is rotating? Which disc has the momentum? Yeah, A is not rotating. Initially is only B. So initially is only B. So I initial is IB. And then omega initial is 150. 150. Okay. 150. Never mind, just I don't want to put in the value first. Just put as omega I. And then final moment of inertia is the combine. They combine together. So we have IA plus IB. Plus together, their moment of inertia. And then we want to find the omega final, isn't it? Okay, as we can see, if the moment inertia has increased, it becomes heavier. Of course, it rotates slower. You surely get the final angular velocity less than the initial. If this is 150, maybe final you get maybe only 100. Instead of 150, you get only 100. Assumption, yeah. So when when the IB only when small moment inertia, you have higher angular velocity. When you have higher moment inertia, lower angular velocity. It's always like that. Conservation of angular momentum. Okay. Now let's put in the value of IA, IB. IB, I have 0.3. Okay, just put in a value 0.3. Initial angular velocity is 150. 150. And then IA plus IB, 0.5 plus 0.3. And then final angular velocity. So happy that we can solve the question, isn't it? So I get 56.25 radian per second. Yes, that's the final angular velocity. Is it smaller? Is it smaller than 150? Whoa, it's definitely smaller, slower than 150. It's only 56 radian in 1 second. He turned only in 1 second. In 1 second, he only turned this amount of radian, this amount of angle. Last time, in 1 second, he can turn 150 radian. Yeah, this time 1 second only turn 56 radian. So very slow. Becomes slower because it becomes heavier. Conservation of angular momentum. Now, let us look at the next question. The energy dissipated in this process. What is the energy dissipated? So the energy dissipated, delta K. Okay, let's dissipated. Initially, they only have the kinetic energy, isn't it? So we just find the changes in their kinetic energy, the decrease in their kinetic energy. The decrease in kinetic energy is converted to heat energy. Energy lost, energy dissipated. So we just find the change in the kinetic energy. So we just use the final kinetic energy minus the initial kinetic energy, which is the change in kinetic energy. So, kinetic energy, we have translational and rotational. Last time we learned about translational, which is half mv squared. Now, rotational motion, for rotational motion, we have mass is like I, V is like omega. We have half I omega squared. When something rotates, when something going left and right, it has translational kinetic energy, half mv squared. But when something rotates, like this is rotating, it has rotational kinetic energy, which is half I omega squared. Use the moment of inertia and the angular velocity. Good. So, final kinetic energy minus the initial kinetic energy. So we use half I omega square final minus half I omega square initial. So just put in all the values. Final, we have, the IA plus IB, IA plus IB. Finally, they attach together, combine together. And then the omega final. Minus, initially it's just the B rotating, so just IB. So you just put in the values that you already had. This is IA is 0.5, 0.5 plus IB is 0.3, and then omega final is what you get just now, 56.25 square minus half. IB is 0.3. Omega initial is 150. Okay, yeah. So what is the energy? I got negative 210938 joule. Why is it negative? Negative means kinetic energy decreases. Kinetic energy decreases. The changes is the kinetic energy decrease. Why the kinetic energy decrease? Because loss of kinetic energy changed to heat energy and dissipated loss. So the energy loss is, so just want the value, how much energy is lost? 2109.38 joule. This amount of energy is lost. No need to put the negative. The negative last time, it just means something decrease. The changes is decrease. So this time, I just want to find the amount the amount of energy loss. So the amount, no need sign. Amount of energy loss is just put positive. Just want the size, the amount loss. So which is also 2.1 kilojoule. Yeah, and this is 2 exponent 3, so kilo. Okay, so now is it correct so far? My omega final 56.25. Yes, 56.25. My kinetic energy loss is 2.1 kilojoule. Yeah, energy loss is 2.1 kilojoule. Okay, good. Now, what happened to the dissipated energy? So the energy is heat. Yes, kinetic energy has decreased. Decreased, why? Because it converted to heat energy and dissipated or lost. Okay? So that's it. Yeah? For conservation of angular momentum. So you learn something new. The momentum is I omega. Rotational kinetic energy is half I omega square. So when the moment inertia increase, omega will decrease based on the conservation of angular momentum. Okay, and yeah, so when something decrease, mostly it's because it convert to other form of energy, which is heat energy loss. Okay, thank you for your time watching. I'm so appreciate, love you all. See you in the next upcoming videos. Bye.